Right, here are solutions to quiz 2 for Math 111. First problem, we're asked to evaluate the sum of these two radicals. What you will need to know, well, the easiest way to do this is to figure out the prime factorization for each of these guys. 54 is 9 times 6, which is 3 times 3 and 3 times 2. In other words, 54 is 2 times 3 cubed. And similarly, 16 we could write as 2 to the 4th power. If you kind of go through all this. And I think that's helpful because, well, maybe I'll write one more step in here. The cubed root of 54 is really just saying what is the cubed root of 2 times 3 cubed. And so the way I teach people to write these are what I call good radical and bad radical. Good one over here, you put everything that's a perfect cube, and the bad one, everything that's not a perfect cube. And then the cubed root of 3 cubed is 3. So what we get is the cubed root of 54 can be written as 3 times the cubed root of 2. If you do that exact same thing for the cubed root of 16, noting that 16 is 2 to the 4th, and we can put 3 of these 2's under the good radical side, and the remaining 2 under this bad radical side, and get that the cubed root of 16 is 2 times the cubed root of 2. So then what we can do is say, alright, the cubed root of 54 plus the cubed root of 16 is the same as asking what is 3 cubed root of 2 plus 2 cubed root of 2. That is, I have 3 of these things, and then I want to add 2 more of these things. So now I have 5 of these things. So that ends up being my final answer. And I'll move on to part B. Part B asks us to simplify this mess. Again, it'll be helpful to have a prime factorization out here. So note that 72 is 9 times 8. And 9 is 3 squared, and 8 is 2 cubed. So I could write the square root of 72 using my good radical, bad radical. Let's see, under the good radical here, I could put 2 of these 2's and both of these 3's, and I'm left with just a 2 over here. So what I get is 2 times 3 root 2, or 6 root 2. So with all these simplifications, it makes this problem a little bit easier. We're trying to figure out what is 6 over the square root of 72, but the square root of 72 is just 6 root 2. So we can cancel out the 6's and call this 1 over root 2, which we can rationalize, multiply the top and the bottom by square root of 2, to get root 2 over 2 is our final answer. Alright, that's the end of problem 1. Moving on to problem 2. Here in part 2 we have equations we're supposed to solve. That's not even an equation. Guess I can just put this in and fix it later. Need an equal sign to be an equation. Okay. Solve this thing by factoring. So solving by factoring is easier when the leading coefficient is a 1. When it's not a 1, you have a couple of options. You can do this guess and check method, but I prefer to do the factoring by grouping method. So what I'm going to do over here is I need to find 2 numbers and it's going to need to multiply to a times c to 4 times negative 9, which is negative 3, negative 36, 4 times negative 9, and add to whatever b is, whatever this middle term is, negative 16. If you mess with this for long enough, I think what you get is positive 2 and negative 18 does this trick. But we haven't factored this. This is just the first step. Maybe I even write that step 1 in this factoring by grouping method. We then go over here in step 2 and we replace negative 16x with 2x minus 18x. That is, we write this as 4x squared plus 2x minus 18x minus 9. And so we still haven't factored this, but writing this with 4 terms actually makes it easier to factor. We can factor by grouping. you look at these first two terms and you look for their greatest common factor. They both have a 2x in them. If you pull out a 2x from both of the terms, you'd get 2x plus 1. And so the question becomes, what can we pull out of these second two terms to be left with 2x plus 1? And the answer to that is -9. So now you view this as two terms, and both of these terms, here's one of them, there's the other, have a 2x plus 1 in them. So you pull out a 2x plus 1, and you're left with this 2x and this -9. So now that we've factored the left-hand side, we can solve this thing. We can say, all right, 4x squared, maybe I'll just write it down here. Say, all right, we were trying to solve this equals 0. So we have something times something equals 0. That means either 2x plus 1 equals 0 or 2x minus 9 equals 0. So if I subtract 1 from both sides, I get 2x equals -1, x equals -1/2. If I add 9 to both sides, I get 2x equals 9, x equals 9/2. Alright, kind of had to jam it in there, but that is the solution here. We get these are our two answers for solving this equation. Now we want to solve by completing the square, so do the same thing again. Maybe I should switch colors. It's the exact same equation, so we should get the same answers. I just want to see you do it a different way. I think a handy first step would be to divide everything by 4. So if you divide everything on the left by 4, you get this. You divide 0 by 4, you get this. And now I can complete this. I can complete the square. I like putting those blinders in there. You don't have to do it that way. And then writing in what I know will always be the same, which are those parts. And then now that I have all the pieces in here, I can do the completing the square thing. I need what's inside these blue brackets to be what's inside these blue brackets. Put half of the -4 there, and then -2 squared there. And so this is an equation I can solve. See, I guess I should get rid of these blinders. What am I doing this in green? And I got x minus 2 squared minus 4 minus 9/4. Might be helpful to get a common denominator, so go ahead and do that. And so I got x minus 2 squared minus 25/4 equals 0. And if I add 25/4 to both sides, I get x minus 2 squared is equal to 25/4. Take the square root of both sides, and I get plus or minus the square root of 25/4, which is just 5/2. So for my final answer, I just have to add 2 to both sides and get x is equal to 2 plus or minus 5/2. 2 is 4/2. It's supposed to be a 2 on the bottom. 4/2 plus 5/2 is 9/2. 9/2. 4/2 minus 5/2 is -1/2. So those are my two solutions. Maybe I'll write this or this. It's bad notation. Let's do it this way. X equals. And I should check that up here. 9/2, -1/2. Good. I ended up getting the same answers. Okay, solve another one of these. These are the square root ones. What you do with these square root ones is to get the square root by itself. To get the square root by itself, I'm going to add 1 to both sides of the equation. Then square both sides of the equation. Then solve for x. So what I get for my final answer is x equals 3. It's a good idea to check your answers in these problems. In this case, I don't think it was necessary, but it's worth checking. We can check. We could say, is it really true that 2 times 3 plus 10 minus 1 equals 3? Well, let's see, that's root 16 minus 1 equals 3. 4 minus 1 equals 3. Yeah, that looks good. The only time it really matters to check them, well, the most important time to check them, I guess you should always check them to be careful, but when we have an x outside the radical, we'll get 2 solutions. think there are some in the homework like that, and only one of the two solutions will work. But for our purposes, that's perfect. That's the end of this quiz.